Welcome to module 8 of database management systems. We have been discussing basic SQL queries, and this is the third and closing part of that introductory discussion that we started in the sixth module. So, just to quickly recap, these are the things that we did in the last module, completing the understanding of basic operations, the null values and aggregate functions. In the current module, we want to understand a feature which is very important in SQL query forming. It is called the nested query, or more formally nested subquery in SQL. And we would like to understand the process of data modification, and those are the two things that are outlined here. So, let us start with nested subqueries. A subquery is necessarily a select from where expression that is nested within another query. These are the key things, where expression. So, it is nothing new over what we have already learnt, but it is a part of another query. It is nested within another query, and that is the reason it is called a subquery. So, it by itself is not the result. This will be used, this is a select from where expression that will be used in a nested form in some other query to actually generate the result. So, that is a nested subquery. So, the nesting can be done in one or more of the three clauses that a select from where SQL query has. An attribute can be replaced, a relation can be any valid subquery, or a subquery could form the part of a predicate in the where clause. All of these are possible. So, we will discuss them one by one. So, first we will start by discussing how subqueries work in the where clause. The common use for having subqueries in the where clause is to perform different kind of tests for membership, comparison, cardinality and so on. So, let us look at this. You have already seen this query before. Find courses offered in fall 2009 and in spring 2010. Earlier we have shown different ways of coding this. Now, we are showing yet another way to be able to code this in SQL. So, first from the beginning, certainly we need the courses. So, the select clause is trivial. It has to be the distinct course IDs. Certainly, the information will come from section, which has information about offering of courses, as we have also seen already. So, those two are no brainer. Now, let us see how do I find courses that are offered in fall 2009 and in spring 2010. So, again the first part, the courses offered in fall 2009 is coded in this part, in part of the where clause predicate, where it is a semester has to be fall and year is 2009. So, this part is also done. Now, we need to ensure that whatever, I mean if I assume that after this part were not there, then this will only give me courses which were offered in fall 2009. But we want the courses that are in fall 2009 and in spring 2010. So, we do something interesting. What we do is we write a separate query here, which is courses that are offered in spring 2010. Select course ID just in the same way, select course ID section semester year. So, this particular query will give me the courses offered in spring 2009. So, what do we have? In one part I have, so if you look at this part, this courses that happened in fall 2009. If you look at this part, courses that happened in spring 2010. Good. Now, what I want? I need that I am interested in the courses that happen in both. So, for a course that exists here, I want to specify that course ID must be present here. So, what I am checking for? I am checking for a set membership. This is a set, right. So, I am trying to check whether that course ID which is being selected in the first part exists in is another keyword in this particular relation that is specified by the second part of this query, which is courses offered in spring 2010. If it is, if the course ID is present, then that course must have been offered in both the semesters. If it is not present, then it is offered only in fall 2009 and not in spring 2010. And certainly, the courses that were not offered in fall 2009 and only offered in spring 2010 will feature here, but they do not exist here. So, they will never come up for test. So, as a result, what I get finally is the effect of computing courses that are offered in fall 2009 and in spring 2010. This part of the query which I used as a part of the where clause is my nested subquery, and in this case, as you have seen, it is used for set membership. And this is a basic idea of using nested subqueries, that is, a nested subquery will always give you a relation. So, you try to put that relation in the right context of the where clause, from clause or select clause, and then make use of it in building up your logic. So, let us run through some examples. This is what you are saying is earlier one was the courses offered in both. Here we are trying to do kind of the difference, saying the courses offered in fall 2009, but not in spring 2010. Certainly, we easily get that by changing the membership to negation of the membership. Earlier it was in, now you do not in, you will simply get that. It is up to you to take some examples and convince yourself that this kind of a nesting will work. We find the set of find the total number of distinct students who have taken the course section taught by the instructor. ID, some ID is given. So, again we form a nested query. Here is a nested query which tells me the courses taught by this particular teacher 10101, and then we check set membership in terms of this course ID, section ID, that is fields of the takes relation, to see that whether that particular tuple can exist in the course offered by the specific teacher. If it does, then take out that ID, which will turn out to be the student ID in this case, because that is the text relation has the student ID. Take out the student ID and count it as distinct. So, this can simply give you the answer to this query. Obviously, we agree that this can be written in a simpler form also, but we are including it here just for the sake of illustrating the feature. There is another clause called the sum clause. Look at this, find names of instructor whose salary is greater than that of some, which means at least one instructor in biology department, and we have already seen this coding before. Now, we can do this in terms of the nested query by using, again, this is certainly the salary of instructors in biology department, and we are doing greater than some. That means that the salary here being checked must find at least one record here, so that it is greater than that salary value. So, it is greater than some is a nice way to find existential records using the nested subquery. The logic of sum clause I have detailed out here. So, we will not go through each one of them. in this discussion. I leave it on to you to study and convince yourself that you understand the semantics of sum. So, similarly, we have an all clause which say that if we want to say find the names of all instructors whose salary is greater than the salary of all instructors in the biology department, in place of sum we will write all, and it will check, every salary will check with the whole set of salaries in this subquery, and only if that is greater, then that particular record, that particular name will be included in the result, otherwise it will be excluded from the result. Similar to sum, there is a basic semantics of all, which is also worked out here, and I leave that to your study at home. You can test for empty relations by using the exists construct. So, if you say exists R, then that is a predicate which mean that R is not empty. If R is empty, then exist is false, and not exist is the negation of exist. So, it can be used to specify the query like find all courses taught both in fall 2009 and spring 2010. So, all that you have to do, earlier you did it by set membership. So, now you are trying to do this by this exist. So, you are saying that this is again the same query which gives you the courses that are in spring 2010 and also in this fall 2009, and you check whether this relation, whether this particular nested query is an empty one or not. If it is an empty one, then exist will fail and the whole where clause will fail. If it is not an empty one, then you have found such an entry, it was offered, and therefore, it will get included. So, these are just different ways of expressing similar things, but what you should note is the nested subquery is a very convenient way to frame up the logic in multiple different ways that you would like to do. So, these are the different names given, the correlation name and the correlated subquery. Incidentally, the nested query is often referred to as the inner query, and the query in which the nesting has happened is known as the outer query. Here is another example which illustrate the use of not exist, so which I leave it for your own study. We can check for uniqueness, that is test for absence of duplicate tuples by using the unique keyword. So, we can you can see here that here is a nested query, and we are using unique to find out all courses that were offered at most once in 2009. So, if a course was offered more than once, then naturally multiple records will feature, and the result, the unique will fail. Unique will be true only if there is only one entry which shows that it is offered at most once in that semester. Now, we move on. So, we have been discussing about subqueries in the where clause. Now, we move on to subqueries in the from clause. So, as we have already seen, a nested subquery is a relation. So, it can naturally be used in the place of any relation that we have in the from clause. So, we are trying to find out average instructor salaries of those departments where the average salary is greater than 42,000. So, look at this is a nested subquery. So, what is been found here? This will compute the average salary, department wise average salary, which we have already seen, group by department name, and then you do average on the salary and you give that field a new name. So, which means that this is equivalent to having a relation which has two attributes, depth name and AVJ salary. So, from that you are now trying to do the selection, and what is the condition? That the average salary has to be written. So, you already have that as a part of the field, the average salary. So, you just need to put that in the where clause, and you have only those coming out of this particular relation where average salary is greater than 42,000 to be selected in this select query. So, these will feature in the output of this selection. So, that is how you can very easily use a nested subquery in the from clause, and for this we did not, earlier we solved this problem using the having clause, but here we will not we did not need the having clause to do this. There is this is another way. So, here what we have done is the same. If you look into the nested subquery, this is actually the same. All that we have done, we have given it a new name by the renaming feature, and then this as if becomes a relation, and on that the computation is done. Rest of it is similar. There is a with clause that provides a way of computing a temporary relation, and that can be subsequently used. So, let us look at example. So, we are trying to find all departments with maximum budget. So, this is my basic query. We want to find department name, department.name, that is the department's name, from the department table, and the budget must be same as the maximum budget. So, for that I need to know the maximum budget that exists across the department. So, look at what has been done here. We have a nested query which aggregates the maximum budget from the departments. So, this gives you the value of the maximum budget. We make that into a temporary table, max budget, with an attribute value. So, this is renaming. So, you can see the renaming is being used in very interesting ways. So, this is my nested query that gives me a relation, and this is my definition of the relation. So, max budget now is a temporary relation, a relation that I use subsequently in my from clause, and with allows me to do that. This relation will not be available otherwise. After this query, this relation will not exist. This is just a temporary one computed for this query. So, this gives me the budget value, this gives me the department and department specific budget, and this condition tells me that I can choose all the departments which has the maximum budget. A very nice way of using this. So, with clause can be used in even more involved way. Again, this is an example which is more complex use, and I leave it to you to practice, study and understand. We move on to subqueries in the select clause finally. A scalar subquery is one where there is a single value is expected. So, we can very easily use that in the select. So, what if you look at this part, which is the subquery. So, you are saying list all departments along with number of instructors each department has. So, this condition tells that from the instructor we are taking out that department name where the instructor works. So, you count them and then you form that as a new attribute. Mind you, while we were using this in the from clause, we were treating that as a relation, because nested query will give a relation. But here in the select clause, the entities are attributes. So, this as is renaming of attribute, which mean, but this is a relation. That is why this notion of scalar subquery is required. That is, though this is a relation, what does the relation compute? It computes a single value. So, that value we are putting as an attribute name num instructors. So, we have department name and the number of instructor therein for each and every department that we actually have from the department list. So, it is a very interesting way of using this nested subquery in terms of the select clause. Naturally, since in the select clause I cannot have every entry in the select clause has to be an attribute, pure relations are not possible. So, if the subquery returns more than one tuple, which cannot be conceived as one or more attributes, then it will be a runtime error. That will not be allowed, because we do not know how to handle multiple tuples in terms of a select clause. Okay. Next we move on to discussing the modifications to the database. How do we modify the database? So, we will look into some of the ways of changing the records or removing records from that. Earlier we saw a delete of record which removed all records from a relation, but now we will see selective deletion, insertion and update of values. Now, deleting all instructors are easy, delete from instructor, all records are erased and this becomes an empty table. But suppose we want to delete all instructors from the finance department, then like we do in the select from where, we again use the where clause as a predicate and say that delete from instructor, but you do the deletion provided this condition is satisfied, that is department name is same as finance. So, it is very similar to the select from where, but the effect is unlike select from where no tables change in the database. Here the table is actually changing, because these instructor records are deleted whose department name was finance. The third example shows delete all tuples in the instructor relation for those instructor associated with the department located in the Watson building. So, a Watson building may have multiple departments. So, all instructors who worked on those departments which are located in the Watson building, that you remove. So, you do this is again you are using nested query. Now, you know how to use a nested query. So, you use nested query which will give you the names of departments, which it gives you a relation with a single attribute with names of departments housed in the Watson building. Then you use the set membership to check whether a particular department belongs to that set. If it does, then it is in Watson building, otherwise it is not in Watson building. If it does belong to the Watson building, then this where clause becomes true and the corresponding instructor record is deleted, and that is how this whole different kinds of selective deletion can happen. Delete all instructors whose salary is less than the average salary of instructor. Again, this is, so you compute the selection subquery which computes the average salary and check if the salary is less than the average salary and delete that. Sounds straightforward, but just wait a while, just wait. I mean, did we do a right thing? An average salary is computed by taking the sum of all salaries in the relation and then dividing it by the number of relations. This has to be the average salary. Certainly, if I remove a record, then the average itself will change. So, if I write the query in this manner, then what I am saying on the face of it looks correct, but then actually can it be correct, because the moment a condition is satisfied and that record is deleted, this average value itself has changed. So, that is not, so that will depend, then the result will depend on the order in which the deletion is happening, but that is not what was meant. What was meant is take all the records for the present, find out the average, find out all records which have a salary less than that average and remove them. So, this initially easy trivial looking solution is not actually correct. So, you will have to do the solution in 2 stages. First, compute the average salary, find all tuples to delete. Next, delete all tuples found above without recomputing the average. In the present solution, the average is recomputed, which is the wrong thing. So, again I will leave that for you to solve. We move on to looking at modifications in terms of insertion. So, we had seen this earlier. We can add a new tuple by insert into, then the relation name, then you say values and the tuple of values. We can specify the, if we do not remember the order of attributes in the relation, then we can also specify the order in which we are actually giving the information. So, you are saying insert into course, and what we have done here is we have actually specified the order in which the attributes occur, and that order and the order of values must be the same. In the first case, this order of values is decided by the order of the attributes that exist in terms of the create table. Add a new tuple to student with total credits set to null. That is, I do not know, if you are adding a student, initially it does not have a credit, right. The credit is a nullable field. The credit will be earned after the student has gone through the courses and all that. So, if I do not know the value of a field, then I can write null null, which is a special value designating unknown for at the time of insertion. Add all instructors to the student relation with total credit set to 0. So, I can also combine insert with select. So, we are taking the first part, this part is selection, which generates a whole lot of records having ID, name, department name and the total credit set to 0 from the instructor, and insert them into the students. So, these will get inserted into the students. Select from where statement is evaluated fully. So, this first select from will be done before any of its results are inserted in the relation. So, that is the basic condition that SQL guarantees, because if that were not the case, then such situations will become circular and will cause problem. Updates can be done based on particular values. So, you can update a table based and what it means that you could update the values of specific fields. So, here in the first case we are trying to give a 3% salary raise for salaries which are more than 100,000 and some 5% raise for salaries which are less than equal to 100,000. And mind you, this order in which you do the update is important, because if you do the later update first, then someone who had qualified in the later part was less than 100,000, with the increase will become more than 100,000 and will also qualify for the second one. So, that will become wrong. So, update often is dependent on the order, and therefore, you have yet another feature to take care of this when you have a specific order to do things. it is called the case. So, you say when salary, case is a new keyword, when is a keyword, when salary is less than equal to 100,000, then this is how you hike, otherwise this is how you hike. So, it looks more like the if statement of C++. You can do updates with scalar subqueries. We have seen scalar subqueries already. So, you can use a scalar subquery. Again, I would not go through the details, please study and you will be able to understand. So, these are different examples. So, to summarize, we have introduced a very powerful feature in SQL query known as a nested subquery, where we can write a select from where expression as a part of the where predicate, or as a relation in the from clause, or as one or more collection of attributes in the select clause, and it can be used in several other places also. We have seen the ways to perform data modification in terms of deleting, inserting and updating records, and we have also seen how nested subquery often may be very useful not only in terms of performing a query, but also in terms of performing certain data modifications.